Welcome back to Basic Mathematics. In this video, we're going to be looking at solving one-step equations. Equations are the place where variables really start to shine in mathematics. Equations are rules that tell us that two expressions have the same value. And by knowing just that and knowing a couple of things about the equations, we can figure out the values of variables that we can't measure directly. In many different situations, in most fields of study that rely on mathematics, this idea of solving equations is the most powerful tool in mathematics. So let me get my head out of the way and let's start looking at what I mean by that. An equation is a rule which claims that two expressions have the same value. When you see the equal sign, you often think about it in terms of evaluation. Right? 3 plus 4 equals 7. If you evaluate 3 plus 4, you get 7. That's certainly true, but equations can be more general than that. 4 plus 5 equals 3 squared. It's true. 4 plus 5 equals 9. 3 squared equals 9. There's no reason that that happens to be true. I just coincidentally found some numbers where when you perform this operation on these numbers or when you perform that operation on those numbers, you get the same thing. In mathematical modeling, in the process of trying to use math to understand the world, looking for situations where two different equations give you the same value is, in essence, the entirety of the discipline. That's all we're trying to do. An equation may be either true or false. And that's something we ran into when we were talking about proportions. Proportions are equations, and sometimes proportions ended up to be false. A claim that two fractions were equal wasn't true. There are a lot of places in mathematics where that is an interesting thing to study. In this course, in this series of videos, I'm not going to be looking at anything where that's the case. What I am going to be looking at a lot is a conditional equation. A conditional equation is an equation that contains a variable and a conditional equation is only true for certain values of variables. Most of the equations we look at in this course are going to contain one variable, and there will be one value for which the equation is true. That's not always the case. There are some equations that are true for 2 or 3 or 4 or any number of different values for the variables. There are equations that have 1, 2, 3, 7, 48, 256 different variables in the equation. We call these values the solutions of the equation. For example, we might be asked to determine if x equals 3 is a solution to the equation x squared minus 5x equals negative 6. In order to determine that, we evaluate the expression on each side of the equal sign for that value of the variable. So we look at 3 squared minus 5 times, that's not a 3, 5 times 3, and we see if that is equal to negative 6 or not. Nine minus 15 is in fact negative 6. We end up with a rule that says negative 6 equals negative 6, which is absolutely true. If we're asked to determine if x equals, actually not 2, you're welcome to go through and show that x equals 2 also is a solution. I wanted to look at something that is not going to be a solution. So how about 4? If we want to determine if x equals 4 is a solution, we can do the same thing. We will have x squared minus 5x equals negative 6. 4 squared minus 5 times 4. 4 squared is 16. 5 times 4 is 20. And 16 minus 20 is negative 4. I hope you all agree with me that negative 4 is not equal to negative 6. This is false. So x equals 4 is not a solution to this particular equation. The additive property of equality, a very pretentious sounding name for a very fundamental idea in mathematics. If A is equal to B, then A plus C is equal to B plus C. And A minus C is equal to B minus C. Using the additive property of equality, we can solve an equation. So if I want to solve the equation x minus 5 equals 2, I can add, in this case 5 will be appropriate, to both sides of the equation. I can take x minus 5 and add 5. I can take 2 and add 5. In the process of combining like terms, x minus 5 plus 5 is x plus 0, and x plus 0 is simply x. So I get that if x minus 5 is equal to 2, then x is equal to 7. Similarly, if I have something like 9, that doesn't look like a 9, let's try that again. 9 is equal to 4 plus x. In order to get x by itself, I can subtract 4 from both sides of this equation. Nine minus 4, of course, is 5. And on the right-hand side, I can rearrange that a little bit to see clearly that combining like terms, I will have 4 minus 4, which is 0. And anything plus 0 is that thing. So 5 is equal to x. Another pretentious sounding rule, the multiplicative property of equality. If A is equal to B and C is not 0, then A times C is equal to B times C, and A divided by C is equal to B divided by C. This is another rule that will allow us to solve a number of equations. I want to point out that the C is not 0. In the last part, dividing by 0 is undefined, so that's why it's important to have C not 0 there. In the rule above, though, A times 0 and B times 0. You'll be left with 0 equals 0, which is certainly true, just not helpful. Multiplying both sides of an equation by 0 destroys all of the information in the equation. So for example, if I have the equation 5x equals 45, I can notice that I might divide by 5 on the left-hand side and on the right-hand side. And on the left-hand side, multiplying and dividing by 5 cancel each other out. 5 divided by 5 is 1. So I have 1 times x. On the right-hand side, 45 divided by 5 is 9. And of course, 1 times anything is that thing. So 1x is simply x. I get x equals 9 as my result here. The really nice thing about the multiplicative property is that you can use it to make fractions disappear. 3/5 x, sorry, I actually wrote the wrong thing down. 3/5 x is equal to 4/5. In this particular case, if I multiply 5 times 3/5 x is equal to 5 times 4/5. Well, here, multiplying by 5 and dividing by 5 cancel each other out, leaving me with the equation, right? 5 divided by 5 is 1, so I have 1 times 3 times x, and I have 1 times 4. 1 times 3 times x is just 3x. 1 times 4 is just 4. And then from there, I can use the property with division like I did before. To get 3x divided by 3, 3 divided by 3 is 1. And you can either leave the answer as the improper fraction 4/3 or as the mixed number 1 and 1/3. As always, pay attention to the problem. Very often there are instructions that tell you what you need to do here. Before I wrap up this video, I want to show you one kind of interesting trick. Sometimes you'll end up with variables in interesting places. (7x minus 6) is equal to 6x. I have an x on the left-hand side and also on the right-hand side. So an important rule to keep in mind is that when you have x in more than one place in the equation, on the left and on the right, you need to use the rules to get all the x's on one side. If you have x appearing in multiple places on one side, you need to use rules of simplifying to get it down to just one occurrence. In this case, I am going to simply subtract 6x from both sides of the equation. 7x minus 6x is 1x, and 6x minus 6x is 0x. 1 times anything is that thing. 0 times anything is 0. And we have simplified the complicated equation, 7x minus 6 equals 6x, into a more straightforward equation, x minus 6 equals 0. From here, I'm going to continue to use the addition rule. X minus 6 plus 6. Minus 6 plus 6 is equal to 0. And 0 plus 6 is 6, and x plus 0 is x. All right, so it takes a little bit more doing, but when you have more complicated equations like this, you can still use just those two rules, the addition rule and the multiplication rule, or more formally, the additive property of equality and the multiplicative property of equality. And with just that, you're able to solve these equations. With that, I'll wrap up this video. As always, thank you for joining me. Take a look at the practice problems, and I'll see you in the next video.